I hope you all fine. Okay. This is lecture number 5. And as I told you previously that we have to start dynamics. But before we go into the dynamics, actually, there is a very small topic left. So let's complete that topic here, right? And then we'll move forward to the dynamics, which is the next topic here. So let's talk about one last topic, which is definitely associated with kinematics, right? Now, what exactly is that? We already talked about that basically you will have different type of motions. Till now, what we were talking about motion in a straight line. When a body is moving in a straight line, right? But now we are talking about a motion named free fall. Now, what does it mean by free fall, right? When I say free fall, what does it mean? It's simply like, for example, you are standing here somewhere and you're throwing something in the upward direction. Or you're standing on a roof or something and you're dropping something from the top. Now, what will happen? Everything is under the force of gravity of Earth, right? So you can say the movement, or you can say motion under the influence of force of gravity of Earth is called as free fall. Now, what is a difference in the free fall and the general motion? Very important difference. The first important difference is that in case of free fall, the body which is falling from a top, it has a constant acceleration, which is not changing, right? And that is equal to g value, which we called it acceleration due to gravity. And it has a value equals to 9.8 meters per second square, which is a constant value. It means any object, whether it's a heavy object, whether it's a weak object, as far as it is on the earth, the g value is constant. It means that the acceleration due to gravity while the body is falling on the ground from a top is 9.8 meters per second square, right? And the most important thing is the force with which the earth is attracting the body towards itself is called as weight force, which we will going to know, or we will going to discuss in the next lecture. Weight, which is equal to m multiplied by g. M is the mass and g is the acceleration due to gravity, which is 9.8 meter per second. So technically speaking, the acceleration, which is actually the force of, acceleration due to gravity, which is 9.8 meter per second square. This is a constant acceleration if the body is moving in a free fall, right? So it's not changing all. And the force with which the body is attracted towards the earth, attracted by the earth, is actually equal to m, which is mass, into g, which is a weight force, right? Now, if we draw a graph, right, remember that in that case, we are neglecting the air resistance. And only force that is acting on a body is the weight force. So if the weight force is acted on a body, like for example, that guy, if falling downward, definitely, then the graph between the time and the speed will be a straight line graph passing through the center. And we already discussed that if a line, the speed time graph, the graph line is passing through the origin, it means that body is moving with the constant acceleration. Constant acceleration, in that case, that constant acceleration is an acceleration due to gravity, which is 9.8 meter per second square. So we are taking that value as 9.8 meter per second square. And this is the case when we are considering air resistance to be negligible. It means that now, what is air resistance? At that point, I want to actually explain it to you. Remember that air resistance is a force that is always opposing the motion of a body. If a body is moving in downward direction, air resistance will always be in upward direction. It simply means that it always opposes the motion of a body. So, if air resistance by chance, if we consider it, it means that the net force acting on a body will be decreased, because downward force, there is a weight force, upward force, there is a air resistance. So, if we subtract both of them, then the net force, the overall net force acting on an object will be different, definitely smaller than the case which is right now. At this point of time, there is only net force acting on a body which is in the downward direction, and that is your weight force, right? And that is in the downward direction. In that case, the only force acting is that. That is the reason body is moving with the constant acceleration, which is given. Now, let's take the example now. Now let's consider the air resistance and let's see what will happen when we consider the air resistance. Let's take an example of a paratrooper, a parachuter who just jumped from the plane, and that is the motion of a paratrooper. Previously, it was when in the absence of air resistance, and this is in the presence of air resistance, right? Now, what will happen? Let me explain it to you with the help of a example. That paratrooper or parachute or whatever, once he jumped from a plane, as soon as he jumps, he will accelerate first. Why he will accelerate? Because as soon as he jump, there is no force other than the weight is acting on it, because which is acting in the downward direction. This is just before the paratrooper just jumped from the plane, right? Now, initially, these arrows are showing the magnitude. Bigger the arrow, bigger the magnitude, right? Now, this accelerates and the weight force is acting on the object. Now, what will happen? Slowly, the air resistance start producing. Why? Because there is a force acting in the downward direction. So air resistance acts in the opposite direction as well. As soon as the air resistance start existing, you can see this arrow is smaller, this arrow is bigger. Let's suppose if the weight is, let me give you an example. If the weight is 4 Newton, the force unit is Newton, which we will talk about later on. And let's suppose if the air resistance is 1 Newton, the net force acting on this object is 3 Newton in the downward direction, right? Net force in the downward direction is 3 Newton. So what exactly is happening? Due to application, due to introduction of this air resistance, the body start decelerating. Speed reduces. The acceleration decreases. And as the acceleration decreases, body decelerates. Now, this thing happened and air resistance keep on increasing until a situation occurs where air resistance and the weight force are equal in magnitude and opposite in direction. Now, what will happen? Overall net force will be 0 Newton. Now, there is no force on it. The problem is, if there is no force, that object should be in a rest condition, but it's not in rest. It is in equilibrium condition, and we call that equilibrium as dynamic equilibrium. Remember that equilibrium conditions are of two types. One condition is called as static equilibrium, and the other equilibrium is called as dynamic. In static equilibrium, the condition is, let's suppose you are applying 2 Newton here in the right side and 2 Newton on the left hand side. Both are cancelling each other out. So you are in a state of rest. So the result is rest. In that case, both the forces acting on an object are the same magnitude but opposite direction. Net force is zero, but body is moving, and body is moving with the constant velocity. Acceleration is zero. And if there is a constant velocity, it means there is no acceleration. That constant velocity or uniform velocity is called as terminal velocity. So terminal velocity, if somebody will ask you what is terminal velocity, then terminal velocity is the constant or uniform velocity at which the net force acting on an object will be equal to zero. So there is no net force acting on an object. Body is moving with the uniform constant velocity. Right? Now, resultant force is zero. Next, as soon as this paratrooper opens up the parachute, what will happen? Suddenly, the air resistance increases. You can see the longer arrow. The weight force is reduced. Again, deceleration, a greater deceleration, because the arrow is bigger. So let's suppose if this is 5 Newton and this is 4 Newton. So you will have a net force of 1 Newton overall force in the upward direction. So decelerate, the body decelerates. And as the body decelerates, speed reduced, right? So what will happen? The body decelerates and a smaller resultant force, and that is acting in the upward direction in that case. Now again, slowly, the point will come that air resistance will be reduced and it comes up to the weight force. At this point of time, again, these two forces are cancelled and the overall force is equal to 0 Newton. Again, the body is moving with the constant velocity. But remember that constant velocity and that constant velocity, the values are totally different. This value may be the greater value, this value may be the smaller, or vice versa, whatever. But it should be new. In that case, it will be the new slow terminal velocity, some other value at which both the forces are actually equal. So that is how the movement of a person or a movement of an object occurs when there is an air resistance, right? Now, what type of graph you can have? Well, you will have the presence of air resistance. You can see that this is a type of graph. I will explain it to you. What will happen initially? At the first, air resistance is smaller and the person accelerates. So you can see yourself, this is the speed time graph. So you can say that it accelerates. Now, there are two things I can tell you here. If your graph is like that, it means the gradient of the graph increases. So this graph you can see, and if the graph is like that, it means the gradient reduces, right? Gradient change reduces, right? In that case, what will happen at the first? You can see the air resistance is smaller and the person accelerate initially. That's why you can see the straight, sort of a straight line. As this graph you can see turns, which means that now air resistance is increasing, right? And it means that body start decelerating. That's why you can have curve like that. Gradient reduces. Initially, it was gradient increasing because body is in accelerating mode. But here, the body is in deceleration mode due to air resistance. Now, it keep increasing till the point reaches to a point where body has a constant velocity or constant speed, which means that air resistance is equal to the weight force, or you can say air resistance is equal to the weight force, both the forces are equal, or a body achieved a terminal velocity. Then, as soon as the parachuter opens the parachute, you can say the body decelerates, so speed goes down. It goes down, 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 slowly, 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 slowly. Again, a new velocity will achieve eventually. At this point of time, again, upward force and the downward force cancels the effect of each other, and you will again get a terminal velocity, which is a constant velocity. Again, you will achieve it. But this time, the terminal velocity is different. Smaller velocity, but there is a terminal velocity. So basically, what is terminal velocity? Terminal velocity is the velocity which is achieved when the net force acting on an object will be 0 newtons. So that is what the terminal velocity is all about. So technically speaking, this is the uh, concept related to what exactly is the motion of a free fall with the interference of air resistance and without the interference of air resistance. Now, definitely there is one more topic which is a part of that, and we can also take that topic in the part of dynamics, but I will definitely tell you in dynamics. But I may tell you here one thing, that weight is a force which is equal to mg. How this is happening, I will discuss in the next lecture, where I will definitely let you know about the difference between mass and a weight. Let's discuss it here, and we will discuss the exact details of Newton's law and everything in the next lecture. Now, what is mass and what is weight? So let's discuss the differences of mass and weight. What is the difference? If I put mass here and weight here, mass is simply the quantity present in the body. And what is weight? Weight is a force. I already told you for the timing, it's a force of attraction of Earth, right? But we will discuss in detail what is force in the next topic. Weight is a force with which Earth attracts the body towards itself. So this is the major difference. Because this is not a force, this is a quantity, and simply it's a scalar quantity. It's a scalar quantity. A physical quantity having no direction is called a scalar quantity. On the other side, force has a direction towards the center, towards the earth. So weight is a vector quantity. Now the SI unit. SI unit of mass is kilograms. What about the other? SI unit of weight is newtons. Next, how to measure it? It can be measured using electronic balance or physical balance. What about the other one? It can be measured using spring balance. The next point is very interesting. If you have an object, and so the mass of an object can never be zero. Because if there is an object, you can say a mass of an object is zero. It's not possible. So mass of an object can never be zero. Very important point. On the other side, the weight of an object can vary. And why it's varying? As it depends on the value of g, which is acceleration due to gravity. And what is the formula for that? W is equal to mg. So if g value changes, weight changes. It means if the g value is zero somewhere, which is in the vacuum, it is zero. Weight is zero. Right? Even on the Earth, the g value on poles and equator are different. So it means even on Earth, the weight can be different. So this is what the whole topic of free fall is. And we have completed that. Now our full complete section is completed. I have said that in the previous lesson. Sometime as I told you that we have done that, but actually now it's fully completed, which includes the free fall and everything included now. So it is all kinematics, because some topics are like that, that can be a part of dynamics and that can be a part of kinematics as well. So that topic can be a part of dynamics as well, but I'm considering it a part of kinematics. So this is my lecture number 5, and this is all sorted, all kinematics done. In the next class, we will start the dynamics. As I told you previously, we will start with the Newton's law and the terms related to that, like net force, resultant force, and all that. So hope to see you in the next lesson. So you take care and see you in the next lesson. Bye.